All right, who is FondyHeat Robotics? Founded back in 2007. It's a branch of Fondy Fire High School first robotics competition team based here at Moraine Park. And we branched off and we decided, well, let's offer robotics to a younger crowd. So that's what we did. And in 2007, we purchased a number of robotics kits called VEX, and we built VEXes. And the VEXes competed against each other. And then last year, we actually joined a competition called the VEX Robotics Competition, a worldwide competition. And we've got some teams doing that this year as well. Unfortunately, competing with VEX Robotics is very expensive, so that's why we came up with this year's program, and we're going to be building these smaller robots. So today we plan to look at this program a little bit, look at a basic robot, see what it is we're going to be building. We're going to look at a sample of the competition, a quick vocabulary lesson, and then we're going to do what's called populate your brain board. Okay, we've set this up so you can work from home. And if you do work from home, you'll need a few tools. You'll need some small screwdrivers, a soldering iron, some solder, wire cutters, wire stripper, a Dremel tool, hot glue gun, those kind of tools. So we'll be recording these PowerPoints each week, and we'll post them online. If you want to work from home, you'll need these tools. So there it is. That's a FondyHeat Hotbot. And you can see there is a brain board on the Hotbot. That's the green board there with the USB port on it. In the front there's a motor. It is blue. And on my Hotbot, I've got a Connects connector hooked onto it. And I use that Connects connector to attach attachments to this robot. You can see it's got rubber wheels, a battery pack. In the back there is something on the bottom, something that looks like an Easter egg. Well, it is an Easter egg, but we're going to properly call it a skid plate. Lots of wires. Let's look at the top view here. You can see next to the wheels where all those black and white stripes are, there is a device, and that's called a sensor, and that sensor sees those black and white stripes. So as the wheel turns, we can figure out exactly how far we've gone on each wheel. There's another black and white sensor in the front. You can't see it very well in this photograph, but it's right under that blue motor, and it will tell us whether we're seeing lines, black or white lines that might be on the field itself. Also on the brain board, you see another sensor. It's a black sensor, and that sensor is set up to receive signals from a Sony television remote control. So we're going to be able to remote control these robots, which is very exciting. Here's an example of what a typical field might look like. Around the perimeter, we've got approximately 3-inch high walls, and down the middle, there's a 3-inch high wall as well. Around the field, we've got boxes called missions, and those are different things that the robot must accomplish, that they must do. Also, those green things and pink things, those are, believe it or not, frogs. Okay, so one thing we're going to do with the remote controls, we're going to pick up these frogs and put them on the other side of the field. Now these, the two robots on the larger field here, on each 4x4 square, are going to be what's called allied with each other. They'll be allies, and they'll be working together to score points. So if you move, say, your green frogs over to the pink frog side, and the pink frog side robot picks that up and brings it back to home base, well, they score points for both teams. What's a mission? A mission is, well, let me give an example of what a mission might be. Let's say that there is a frog in the middle of a black road, and now this mission must be accomplished autonomously, okay? So you have to program your robot to do this. So maybe out at mission 1 there might be a frog in the middle of a black road, and you need to go out and remove the frog from the middle of the road so it doesn't get hit by a car. So remove the frog from the middle of the road, bring it back to home base, and you score. So there'll be a number of missions set up around the field that are similar to that. So we're going to work together in alliances. We're going to accomplish missions, some of them autonomously, some of them with human control. And again, the perimeter is made of wood. It's about 3 inches high, and then that fence down the middle, that's about 3 inches high as well. So that's an example of what a game might look like. We're also going to be passing out awards at the competition. Did I mention the competition is preliminarily scheduled here for May 19th? And preliminarily, once again, we're going to be holding that at Tyson Middle School. Okay, the first award I'm going to talk about is the Engineering Award. This will require you to document and discuss the engineering process that you went through while designing, building, and programming your robot. What worked, what didn't work, why things work. It doesn't have to be a printed portfolio. It could be, for instance, a blog or a website that you set up, but some sort of documenting is required with this. There's also something we're going to call the Innovative Mod Award. Your robot does not need to look exactly like the robot that I just showed you. It will probably look similar, but you will be allowed to modify your robot, make it work better, make everything about it better. And this award is going to go to the most innovative and effective modifications. And we're going to be limiting the amount that you can spend on the robot to additional that you can spend on the robot to $10. We've got some rules here. If you're coming to the Moraine Park workshops on Saturday mornings, just act decent. Here's the rules that you're going to be expected to abide by, and pretty much if you don't abide by those rules, we're going to ask you to go home, and we're going to ask you to do your building from home and not come to the scheduled workshops anymore. So take a minute to look at these rules, but they're pretty straightforward. Just act decent. Okay, there's something we call the Moodle website, and that's where we're going to post everything. And if you haven't done so yet, go to our regular FondyHeat website where you found out about this and click on the Moodle link. It will bring you to a page that looks like that. And when you click on the FondyHeat Robotics 2012, you're going to see something like this. And what you're going to want to do is create new account. And after you do that, you're going to be brought here, and each week we're going to be posting what happens at these meetings, and all the important information is going to be listed here in this Moodle software, which is located on our server. Okay, so here you see what we've got so far on the Moodle server. So you're going to want to be part of this. You're going to want to get in here. We're going to be posting the software here and so forth, so make sure you do sign up for that. If you haven't done so yet, print out and complete the liability form you'll find here as well. Okay, real quick, some vocabulary as to what we're going to be doing today. Mark LEDs there. LEDs stands for light emitting diodes, and you've got 3 different colors of LEDs. In the middle there, we've got something called a printed circuit board, and on that printed circuit board are copper traces. You can't see them very well, but they're copper traces, and the copper traces conduct electricity, and they hook up all our pieces parts in just the right way so this thing actually works. So a printed circuit board is actually like wires going from one point to another on that printed circuit board. We're going to be soldering all these parts onto that printed circuit board. The shiny thing almost looks like a little piece of candy there with wires hanging out of it is called a capacitor. A capacitor smooths out electronic signals, and we'll be talking more about that later on. The thing with three wire-like looking things there, those are male header pins. And right below that, we've got some larger looking female header pins. As we move down, we've got something that you probably recognize as a USB socket that's going to allow our computer to communicate with our brain board. Very bottom there, we've got a push-button switch. There we've got another deal that looks like a little piece of candy, but this time it's got three wires hanging out of it. That's called a ceramic resonator. And a ceramic resonator, when you pass current through it, it begins to vibrate. And in this case, it vibrates very, very quickly at 12 million times per second. So ceramic resonator. In the middle, we've got an IC. IC stands for integrated circuit. And the particular kind of integrated circuit we're using is called a microcontroller. It's actually a little computer all in one integrated circuit. It's amazing. It's got millions of transistors inside. Transistors, in this case, are little electronic switches that we can turn on and turn off, a million of them at a time, to make it do what we want to do. So that is the heart of your brain board, the microcontroller IC. And right next to that, we've got a socket for that IC. Today we're going to be mounting that IC socket and not the microcontroller IC. That's going to be the last thing to go on the printed circuit board, and it will go in a socket. And finally, we've got those cool-looking stripy things there. Those are resistors, and they do just that. They resist the flow of electricity. So you need to know what all these things are while we're populating our printed circuit board. So we've got a little vocabulary lesson here, and in the next PowerPoint we will actually populate the printed circuit board.